This is a video on solving systems of nonlinear equations. In the previous sections, we've solved systems of linear equations, which would just be two lines, and you would find the point where they intersect to find the solution. Here we're going to have nonlinear systems, which means that you could have a line and then some other type of graph, be it parabola, circle, or whatever it might be, or you could have two parabolas, two circles, etc. And we're still going to use the same methods to solve these, which would either be substitution or elimination, depending on what works best in our case. So if I ask you to solve the system here that has x plus y equals 4, and I'll label this equation 1, and y equals x squared minus 16, I'll label this equation 2. The first thing you should notice is that the first equation is of a line because both variables are to the first power, so we know it's linear. The second equation we know is a parabola. We got this y equals x squared minus 16. The highest power on x you see is 2. The highest power on y is still 1. So this is a parabola. So you have a circle and a parabola, and you should think about, or a line and a parabola, sorry. You have a line and a parabola, and you should think about how these intersect. So not even thinking about this specific example, just what are the possibilities? Well, you could have a parabola and the line going through it and intersecting at two places, which means you have two solutions. You could have a parabola and the line completely missing the parabola, which means you have no solutions. Or you could have a parabola and the line intersecting it just at one point, which means you would have one solution. So you could get 0, 1, or 2 solutions here, and all are possible. Now when we solve this, you'll know what you have based on what you find. So solving this system, x plus y equals 4 and y equals x squared minus 16. First thing I notice is that I already have y isolated here, so I'm going to substitute that in to equation 1. So I'm going to use substitution method in, right? So I'm going to sub, y equals x squared minus 16 into equation 1 for y, because y is already isolated here. If it wasn't, you might want to isolate y. So if I do that, then equation 1, subbing in for y, I get x plus, we end up with y is now replaced with x squared minus 16, and that equals 4. Now, if this was a subtraction sign, you would want parentheses around this to distribute through. But since it's a positive, and it's just a positive 1 in front, you can leave it. If there was a constant in front of this, you'd have to distribute the constant through it. But here, since I don't have to distribute anything through other than a positive 1, I'll leave it as is. And now we want to solve this equation. Now it's all in terms of x. So to do that, we want to get, this is a quadratic equation, we want to get 0 on one side. So I'm going to subtract 4 here, and subtract 4 here, and I'll write it in descending order. So I have x squared plus x, negative 16 minus 4 is negative 20, equals 0. And then we want to solve this, preferably by factoring if we can. Does this factor? Well, we have x squared, so I know I have x times x in front, multiplies to a negative 20, and adds to a positive 1. Well, it'll be a positive 5 times a negative 4, so it does factor. Now, if it didn't factor nicely, other ways of solving that with quadratic formula or complete the square. And then solving each of these, we have x plus 5 equals 0, x minus 4 equals 0. Remember, when you're solving this, set each factor that contains a variable equal to 0. So you end up with x equals negative 5. And here we add 4 and add 4, and you get x equals positive 4. Now, remember, when I did this, these are the x values. To solve a system, use the x and y values, that the ordered pairs, in other words, that represent solution. This tells me I'm going to have two solutions. There's two x values where these two graphs intersect is what it really means. And, how do you find the y values that go with it? Well, the corresponding y values you either sub into equation 1 or equation 2. It doesn't really matter. But what you need to do at this point is, all right, now that we've done this, we're going to find the corresponding y values. So to find the corresponding y values, you do these individually. I'm going to substitute in negative 5. And you can pick either equation like I mentioned. I'll sub into equation 2 just because y is already isolated there. So I'll sub this into equation 2. If I substitute negative 5 in here for x, make sure you have parentheses in the right place. It's y equals negative 5 in parentheses squared because you're replacing x, minus 16. And so I end up with y equals negative 5 squared is 25 minus 16, so I get y equals 9. So the ordered pair is the x value, comma the y value is -5, comma 9. That's one solution. That's one place where these intersect. And the second value I found was x equals 4. And again, I'll substitute in equation 2. It doesn't matter which one you pick, though. So substituting into equation 2, we've got y equals 4 squared minus 16. So this is y equals 4 squared is 16 minus 16. 16 minus 16, I get y equals 0. So the ordered pair, x comma y, remember, it'll be 4 comma 0. So there's two solutions here. All right, and you need the full ordered pair, because the ordered pair is where they cross. If you just give me the x values, you haven't completed the problem. It's the most common mistake people make on the final exam for our course, is that they only give you the x values, they don't give you the y values that go with it. So this tells me that the line and the parabola that we have here intersect at the points -5, 9, and 4, 0. Now, I've drawn this out so I can, talk about it here. Algebraically, we're doing it. I'm going to draw a sketch, kind of like how I drew here, but I'll be a little more specific, but not completely accurate. So if I was to draw this out, you should know what these look like. The x squared minus 16, y equals x squared minus 16 is a parabola. It tells you that, it's shifted down to -16, but it's a parabola. It looks like this. This is one point on the parabola. It's also on the line, right? 4, 0. So this would be at 4, 0 is right here. Remember 0 because, that's where the x-axis is, right? The y value is 0, so we know that's where it is. The other point that we know is -5, 9. So -4 would be here, since we know x squared minus 16. If I set this equal to 0, it gives me, x equals plus or minus 4 for the intercept. So I know this happens at -4, so -5, 9 would be about there. And, the parabola and the line both share those points. That's what our solution tells us. And so this is what's really going on, right? If I was looking at this in terms of an x and y axis, I would have this parabola and this line going through, and it intersects at these points that we're describing here. I'm not asking you to sketch this, it's not really what the purpose of the problem is to solve it algebraically. You should have an understanding of what you're trying to find. So in this case, there were two solutions. It won't always be the case. Let's take a look at another one. If I said to solve the system, I've got y equals x squared plus 6x minus 46, and I'll label that equation 1. Remember, if you're doing this, you should label it for yourself. The second equation will be y equals -x squared plus 2x plus 50. This will be equation 2. And we're trying to solve the system of equations. Now, it doesn't necessarily matter what the equations are, but you should think about what you're finding here. Y equals x squared plus 6x minus 46, that's a parabola. Y equals -x squared plus 2x plus 50, that's a parabola. The second one opens downward because it's got a negative coefficient. The first one opens upward. So what could happen? Well, you could have a parabola here and a parabola here that completely miss each other. You could have, parabolas that just share one point. Or you could have parabolas that, intersect with each other. So again, you can have more than one solution. You could have no solution or just one solution. But to solve this system, the idea is that you want to solve either by substitution or elimination. And sometimes people say to solve by elimination, and you could. Since the y's are lined up here, you would have to multiply this by -1 and then add it to this one, or subtract this. But it might not necessarily give you the easiest way of finding the answer. What I would do is, if I have both of these set as y equals, I would set the equations equal to each other. Alright, so I would set equation 1 and equation 2 equal to each other, because they're both equal to y. So it's like a substitution for y into here, or vice versa. Now the reason you might want to do that rather than elimination is that sometimes these terms don't line up correctly. Sometimes when you do elimination you get the signs incorrect. Like you might just add these but then cancel these, and that's not correct because adding these will give you 2y. So it's easier just to substitute one equation into the other. So when I do that, subbing in for y here in the second equation with the y from the first equation, I'm going to end up with x squared plus 6x minus 46 is equal to negative x squared plus 2x plus 50. Now we want to solve this. Typically when you solve something that's quadratic, you want to get everything to one side and 0 on the other side. So I'll move terms to the left, so I'm going to add x squared to each side. I'm going to subtract 2x from each side, and I'm going to subtract 50 from each side. So this leaves me with x squared plus x squared is 2x squared. 6x minus 2x is a positive 4x. Negative 46 minus 50 is a negative 96. And this all equals 0. Make sure you have the equal 0 in there still. So now we're going to solve this. It's all in terms of x, so we can solve this equation. Try to solve by factoring if you can. If not, quadratic formula works. So I have 2x squared plus 4x minus 96. First thing I'm going to do is factor out 2. So I end up with x squared plus 2x minus 48 equals 0. And then once I've done that, remember 2 in front just stays 2 in front. Factoring x squared plus 2x minus 48. Two sets of parentheses. We have x times x in the front of them. Multiplies to a negative 48 and adds to a positive 2. It'll be a positive 8 times a negative 6. You should know how to factor this at this point. And then you set each of your factors that contains a variable equal to 0. So 2 is just a constant in front, doesn't have any variable with it. You don't set it equal to 0 because 2 is just 2. So we set x plus 8 equal to 0, x minus 6 equal to 0. And then solving here, we subtract 8, so we get x equals negative 8. Here I add 6, I get x equals 6. Now remember what I just found. These are the x coordinates of where these two parabolas intersect. What do I have to do? Well, I have to find the y values. To find the y values, remember how you do it. You can back substitute into either equation 1 or equation 2. I'll back sub into equation 1, but it doesn't really matter. So if I took x equals negative 8 and I'm subbing this into equation 1, make sure that you're subbing into the equation 1 and make sure you put parentheses around that negative 8 when you substitute it in. So you end up with y equals negative 8 squared plus 6 times negative 8 minus 46. And this will give us negative 8 squared. The negative squared becomes positive, so it's going to be 64. A positive times a negative makes us minus 6 times 8 is 48, so minus 48, and then minus 46. And if you do 64 minus 48 minus 46, you could do it in your calculator if you want, just to see it. All right, 64 minus 48 minus 46, and we get negative 30. So you get negative 30 here. So one solution, all right, is the x value is negative 8, the y value is negative 30. So negative 8 and negative 30 is one point where these cross, right, where these curves intersect. We also want to substitute in the other x value, x equals 6. We'll substitute it into equation 1. Again, you can substitute in either equation. So substituting 6 in for x in equation 1, we have y equals 6 squared plus 6 times 6 minus 46. And simplifying this, 6 squared, we got 36 plus 6 times 6, also 36 minus 46. So you end up with 36 plus 36 is 72, minus 46 ends up equaling 26. You could do it on your calculator if you need to. So the other solution where these, remember that solution means where these two parabolas intersect, they intersect at 6 is the x value, comma the y value, which is 26. So if I was writing the solution to this problem in set notation, right, remember you can write the curly braces, but remember it's the ordered pair, so you need the negative 8, negative 30, and the 6, 26. That's the solution to this system of equations here. Those are the points where these two curves, these two parabolas intersect. Let's just take a look at one more here. if we said to solve the system x squared plus y squared equals 9, I'll label it equation 1, and y equals x squared minus 3, I'll label that equation 2. So one thing to point out is that, you know, what types of curves we have. We know y equals x squared minus 3, that's a parabola. The first curve, x squared plus y squared equals 9, we haven't talked about yet, but when you have x squared plus a y squared just equal to a number, this is the equation of a circle. And the radius of the circle is the square root of whatever this number is. So the radius would be the square root of 9, which would be 3. You don't need to know that for this class, but just so you have an idea. So it's a parabola and a circle, but think about what could happen in these cases. If I have a parabola and a circle, well, I could have the circle and the parabola going through it. In this case, the way I drew it, it could intersect 4 times. You could have it so it intersects just twice. You could have it so the parabola actually lands on the circle, and you could intersect 3 times. You know, it could just be on one part of the circle, intersecting once, or you could have no solution, right? The parabola could be completely around the circle. The point being is that you could have either 0, 1, 2, 3, or 4 solutions. So you can't really know from the beginning. You might be able to tell a little bit, but you really wouldn't know for sure. Now, something to make this problem a little easier, we're trying to solve this system. I'm going to do it by substitution. And I'm going to substitute in, it might seem odd, but I'll explain why. I'm going to sub for x squared, right, in equation 2. So I'm going to try to substitute in for that using equation 1. Or vice versa. I can substitute x squared into equation 1 using equation 2. The reason I'm doing this mainly is because then I can have something that's quadratic in either case. If you subbed in for y right away here, right, if you subbed in equation 2 into equation 1 for y, which is the thing that people most likely would see first, that substitution, you'd end up squaring this x squared minus 3, which would give you something to the 4th power. Now, we know how to evaluate those, but it's a little more difficult to work with. So rather than have to do that, if we just substitute in for the x squared in either of these cases, we'll be left with something that has y squareds and y's in there, and we know how to solve that a little easier. So I'll solve for x squared in equation 1 and sub into equation 2. That's how I'm going to approach it. So equation 1 was the x squared plus y squared equals 9. And to solve for that, right, when I substitute in, I need to substitute in for x squared, so I want to isolate x squared. So to do it, we subtract y squared from each side. So I get x squared equals 9 minus y squared, or you could write negative y squared plus 9. Those mean the same thing. But now remember what I'm doing with it. I'm subbing it in right here for this x squared. So I'm going to substitute in into equation 2 for x squared, because I can just replace this as it is. I'm not subbing in for x, I'm subbing for x squared, so I replace the whole thing with just a 9 minus y squared. So that gives me y equals 9 minus y squared, and then minus 3. So I just replaced the x squared with 9 minus y squared, because that's what it was equal to. So we're using substitution like we had before, but in a little bit different way. So this gives me y equals, the 9 minus 3 will just be 6 minus y squared. And solving this, I'm going to, want to get 0 on one side and everything else to the other side. I'm going to do it by moving everything to the left, so I'll add y squared to each side, and I'll subtract 6 from each side. Now the reason I'm doing this is because for a quadratic, you want to get everything on one side and 0 on the other. In descending order, I'd have a positive y squared, a positive y, minus 6 equals 0. And now how do I solve this? Well, I'm trying to solve this by factoring if I can. So I'm solving for y here. Solving for y means I want to factor this down if possible. We've got y times y multiplies to a negative 6 and adds to a positive 1. Will that be a positive 3 and a negative 2, I believe? So you get y plus 3 and y minus 2. Right, 3 times negative 2 gives you negative 6. 3 minus 2 gives you a positive 1. And then solving this, I end up with y plus 3 equals 0 and y minus 2 equals 0. If I do that, subtracting 3 from each side here, I end up with y equals negative 3. Here I'll add 2 to each side, I end up with y equals 2. Now remember, I'm looking for the ordered pairs where these curves intersect. So I found the y values first this time, which is a little different, but same idea. Now I got to go back and find the x values that go along with them. What you can't do is just say negative 3 and 2 are the answers, right? You want the coordinates, you want the ordered pairs. Well, how can you find those? Well, we back substitute into either of the original equations. I'm going to substitute into equation 2, but it doesn't really matter which one you pick. So now we back sub. To find the x values. So if I do that, right, substituting into equation 2, I'm going to sub y equals negative 3 in first. So y equals negative 3 into equation 2. Here's equation 2. I'm going to substitute negative 3 in for y. Remember, make sure you're substituting for y, not for x, right? So sub it in for y. So it would be negative 3 is equal to x squared minus 3. We're going to add 3 to both sides here. So I got 0 is equal to x squared. And if I have to solve that for x, well, what do? You take the square root of each side. When I take the square root, typically I write plus or minus, but when it's 0, right, plus or minus 0 is still just 0. 0 is an unsigned number, so I got 0 is equal to x. So when I substituted negative 3 for y, I got 0 for x, which tells me that I've got the point 0, negative 3 is a solution. Remember, always x then y, even if you found y first. The other value I sub in is y equals 2. Again, I'll sub this into equation 2. Substituting into equation 2. Remember, we're substituting in for y. So we've got y equals 2 here. If I substitute that in, I'm substituting it in right there. So we've got 2 is equal to x squared minus 3. We're going to add 3 and add 3, so I got 5 is equal to x squared. How do you solve that? Well, you solve that by taking the square root of each side. If I take the square root, remember I should write plus or minus in front because there's two possible answers, the positive and the negative square root. If square root of 5 simplifies, you should simplify it. In this case, square root of 5 doesn't have any perfect square factors and it's not a perfect square itself, so it's plus or minus the square root of 5 is equal to x. How many answers is this? This is actually 2 answers. So the 2 answers I got out of this, remember, these are always x comma y. Well, I got 2 x values. I got square root of 5 and negative square root of 5. The y value that goes along with it, well, that's 2. So we would have square root of 5 comma 2 is one answer, and then negative square root of 5 comma 2 is the other answer. So 2 solutions came from this one, only 1 solution came from there. How many solutions do I have total? Well, I have 3, right? All of these are the solutions, right? So my solution set is 0, negative 3, square root of 5, comma 2, and negative square root of 5, comma 2. So making sure that, you acknowledge you do have 3 solutions here, which is okay. You can get 3 solutions, and there's nothing wrong with that. It's important to understand that, the reason we got 3 solutions is that we are in a scenario similar to this, right? Where I said, one point could be on there and then it intersects with 2 other points. So we got 3 solutions. Remember, that can happen. Let's take a look at a couple more. If I said to solve the system, and we'll look at x squared plus y squared equals 6, so I'll call that equation 1. And equation 2 will be y equals x squared minus 16. So I'll call that equation 2. And you might want to try it on your own, but we can do it together. It does have a unique solution to it. First thing you should look at is understanding what types of curves we have. X squared plus y squared equal to a number. If you remember, we said that would be equal to a circle, right? So x squared plus y squared would be a circle with a radius as the square root of whatever that number is. It'd be the square root of 6. Y equals x squared minus 16. We know that's a parabola. So similar to the last example, I'm going to isolate the x squared in this and substitute in for the opposite x squared. So I only have an equation with just y's to the second power. Otherwise, if I was to substitute directly in for y here, I would get something to the fourth power, and that wouldn't work out too well because it's harder to solve that type of equation. So I'm going to solve for x squared in equation 1, then sub into equation 2, all right, for x squared. So in equation 1, I had x squared plus y squared equals 6. To solve for x squared there, I'm going to subtract y squared and subtract y squared, so I end up with x squared equals 6 minus y squared. And now I'm going to substitute into equation 2 for where the x squared is. So this is my substitution now. So we end up with, all right, if I sub into 2 for the x squared, I end up with y equals 6 minus y squared. That's me replacing the x squared minus 16. And then I'm going to try to solve this. And when I go to solve this, everything should be moved to the left, or one side or the other, doesn't really matter. I'm going to move to the left side. Let me combine like terms here first. So we got y equals 6 minus 16 is a negative 10 minus y squared. And then I'm going to move everything to the left side here, but either way is okay. So I'll add 10 to each side. I will add y squared to each side. None of these are like terms, so you can't combine them, but writing in descending order, I've got a positive y squared, a positive y, and plus 10. And this is equal to, on the right side, just 0. Now I want to solve this. Now if I could factor it, I'd like to factor it, but that means I would need numbers that multiply to 10 that also add to a positive 1. And the numbers that multiply to 10 are either 5 and 2 or 10 and 1, so they're never going to add to a positive 1. So how do we solve this? Well, we want to use our quadratic formula, which we've seen in the past. Remember, this is y we're solving for, so we got y equals, remember the quadratic formula, I'm not going to write it all out, but I'll say it out loud, right? We have a, b, and c being the coefficients, so a is 1 here, b is 1, and c is 10. And the formula itself is negative b, so it's negative 1 plus or minus the square root of b squared, so that's 1 squared minus 4 times a, which is 1, the coefficient of the first term, times c, which is 10. And this is all over 2 times a, and a is 1, remember. You're never putting any variables in this formula, right? The formula itself is just the numbers, the coefficients. Well, let's simplify this. We end up with negative 1 plus or minus the square root of 1 squared is going to just be 1, minus 4 times 1 times 10 is minus 40. 1 minus 40 is negative 39. This is all over 2 times 1, which is 2. Now, as soon as you get here, you don't really have to do much else if you recognize this fact. If I have a negative underneath the square root, a negative discriminant, in other words, what can you tell me about the answers here? When you take the square root of a negative, you're always going to get an I, right? You can factor out an I, which means it's an imaginary solution. It's not real, right? So this is not a real solution, right? It's going to be a complex number, if you want to think about it, right? But it's not a real solution, which is really the important part to notice. So if it's not a real solution, then there's no real solution, which means that you can't actually find where these intersect on a graph. So if you get no real solution here, right, that's going to be your answer, no real solution, and you can't really solve this system. It means that these graphs never intersect. Right, so if I got no real solution here, it's telling me these graphs never intersect. That happens only when you're solving and you get imaginary solutions, right, or complex solutions. Something where you get the square root of a negative where you'd have to factor an I out. Square roots are okay, right? In the previous example, we saw that we had square roots and that was fine. But square roots of negatives would not be okay because it would give you imaginary solutions. What really happens in this case, just so you know, not that you have to show it, is if I was to draw this as an x and y axis, just to give you a quick sketch, the y equals x squared minus 16 is a parabola that shifted down to negative 16. It'll intersect here at 4 and negative 4. So the parabola would look like this. And the circle I mentioned, x squared plus y squared equals 6, remember the square root of 6 would be the radius. Well, the square root of 6 is less than 4, because remember the square root of 16 is 4. So the circle itself is centered at 0 and the radius would look like that. So the parabola actually goes around the circle, and that's why there's no solution here. So it's important to understand that. Let's just take a look at one more. This one's actually probably easier than the previous few we've done. So if I said to solve the system, y equals x squared plus 6x plus 7, I'll label it equation 1, and y equals x squared minus 2x plus 25, I'll label that equation 2. You want to pause this and try it on your own. Recognizing at first these are both parabolas, right? The highest power is 2 in both of them. The y's are to the first power, so we know they're parabolas. And then, we're trying to find where the parabolas intersect. Now we saw one like this earlier. If these are both y and they're both equal to y, you could set them equal to each other. Essentially, you're setting, right, equation 1 equal to equation 2. You're subbing in for y into the other equation. And when I do that, I end up with x squared plus 6x minus 7, or plus 7, sorry, is equal to x squared minus 2x plus 25. And then you want to solve this. Typically for a quadratic, you want to get everything on one side and 0 on the other. If I do that here, if I subtract x squared, though, and subtract x squared, I actually end up canceling the x squareds on both sides, which can happen. So I end up with 6x plus 7 equals negative 2x plus 25. To solve this now, since it's linear, meaning the highest power of x is 1, remember you just want x's to one side and constants to the other. So terms with x to the one side, I'll add 2x to each side. So I end up with 8x plus 7 equals, these cancel, so it equals 25. Subtract 7 from each side, end up with 8x equals 25 minus 7 is 18. And then solving this, I'll divide by 8 and divide by 8. So you get x equals, make sure you reduce this fraction. You should leave it as a fraction. 18 divided by 8 reduces by 2 in the numerator and denominator to 9/4. Now remember, x is just, the first part of your coordinate, right? It's not the entire solution. Well, how do I find the y value? I substitute back in. Sometimes people don't like this because they have to substitute in a fraction, but it's really no more difficult than what we've done in the past. So we're going to sub this into either equation. I'll say sub into 1, and when I sub into 1, I would have y equals x is squared now, so it's 9/4 squared plus 6 times x, which is 9/4, plus 7. And when I substitute into here, we're just simplifying these fractions now. 9/4 squared, when you have a fraction squared, you can square the numerator and square the denominator individually, so 81 over 16. Plus, we got 6 times 9/4. Now, if you want to, you can reduce that. The 6 and the 4 share a common factor of 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And then 3 times 9 divided by 2 is really what you're doing here. 3 times 9 is 27 divided by 2. And then we have plus 7. Now, how do you add these together? You should find a common denominator is the answer to that. Common denominator, LCD for all of this is 16. This is where how everything comes back together in math, right? The LCD is 16 here, so you got 81 over 16 plus, now I want to write 27 over 2 as something over 16. 2 times what gives you 16? Well, 2 times 8 gives you 16, so we got to do 27 times 8 in the numerator. 216. So you can't just change the denominator, right? You do it by, manipulating the denominator by multiplication. Whatever you multiply the denominator by to get there, you multiply the numerator by. And then plus, this is really 7 over 1. I have to make it over 16, so 1 times 16 got me to 16. So in the numerator, 7 times 16 is what I need, which is 112. And then we end up with y equals, now remember what you're doing, you're adding these, so you add straight through the numerator now that you have a common denominator, so 81 plus 216 plus 112 is 409 over 16. Does that reduce? No, I don't believe it does, right? 409 isn't even, and all the values that divide out of 16 are, because 16 is 2 to the 4th power, so it's not going to reduce. So you got the y value now, and then the ordered pair, right, the solution here, right, our solution set, if you want to write in a set, is the ordered pair 9/4 x, comma, the 409 over 16 is y. And that would be your answer. Don't let it throw you off if you get a fraction. Most things in the real world don't come out perfect. So, you know, these two parabolas only intersected at one point, and the one point they intersect at was 9/4, comma, 409 over 16. So hopefully that gave you a good number of examples to how to solve these nonlinear systems. It's really the same type of substitution methods we used before, except for now you end up with, you know, potential quadratics when you're solving. And if you do, you really do need to use either factoring or quadratic formula to solve. Don't forget, the main thing is you're solving and you're finding ordered pairs, so you need x and y values for each solution.